Hello, AP Environmental Science students. In today's screencast, we're going to go over Supplement 8, which is in the back of your textbook. This goes over weather basics. All of today's notes are based off of Living in the Environment, the 16th edition by Miller and Spoolman. So like I said, this is kind of a supplement to our regular textbook, but I think this really helps us to understand why things like El Nino and air pollution and all that kind of stuff is actually a big deal and how it circulates over our atmosphere. So we've already kind of talked about weather. Weather we discussed in 7.1, and weather is a local area's short-term temperature, precipitation, humidity, wind speed, cloud cover, and other physical conditions of the lower atmosphere as measured over hours or days. So again, this is going to include things like temperature, moisture content, precipitation, sunshine, cloud cover, wind direction, and speed. And to figure this out or predict our weather, meteorologists use equipment mounted on weather balloons, aircraft, ships, satellites, and radar to obtain data on weather systems. This is then fed into a computer where models predict and calculate the probabilities of different types of weather occurring in upcoming days. So one of the big things we have to look at when we're looking at weather is the front. A front is a boundary between two air masses with different temperatures and densities. A warm front is the boundary between an advancing warm air mass and the cooler one that's replacing it. So warm air is always less dense, so it rises above our cool air. And as it rises, the moisture condenses and it forms clouds or rainfall. So here's my warm air. It's moving in. The cold air is going to shrink or sink below it, pushing that warm air up. As the warm air is pushed up, any moisture that was in a gaseous form over here now condenses into clouds and then can cause rain. A cold front is where the leading edge of the advancing mass is cold air. And as we know from the last slide, cold air is more dense, so it stays close to the ground and it wedges underneath the warm air. This sudden upheaval produces massive towering clouds called thunderheads, and these high surface winds develop, thunderstorms occur, and it's generally followed by cooler temperatures and really clear skies. So once we force that warm, moist air up quickly, it dumps all of its moisture out, and then we have these clear skies. Jet streams are powerful hurricane-force winds that circle the Earth, and they also have a strong influence on weather patterns. They kind of control where fronts travel. If you've ever been in an airplane, they often go high enough to be caught up in jet streams, which helps reduce fuel usage and often speeds up your travel time. We also have to think about atmospheric pressure. So atmospheric pressure results from the molecules of gases in the atmosphere zipping around at very high speeds and hitting and bouncing off of everything they encounter. A high pressure system is going to contain cool, dense air that descends towards the Earth's surface and becomes warmer. Fair weather follows as a result. So we know cold air sinks. As it sinks, it places high pressure on the Earth below it. Low pressure is the opposite. It produces cloudy and sometimes stormy weather because low pressure and low density and warm air. The low rises, its warm air expands and cools, and when the temperature drops, the dew point is reached, which is where water condenses, forming clouds and causing rain. So as that warm, moist air rises, it forms clouds. Clouds release their moisture. Another thing we have to talk about is upwelling. And upwelling is the upward movement of ocean water, which brings cool, nutrient-rich water up from the bottom of the ocean to the surface, which helps to support large populations of phytoplankton, zooplankton, and fish. Upwelling is a major concern of the fishing industry because when upwelling is occurring, fishing industry booms. If upwelling stops, it dramatically drops off as well. So we will spend a lot more time in class talking about El Nino and La Nina, but just for a general quick overview, usually trade winds in the Pacific Ocean blow east to west, so northeast to northwest, which causes upwelling along the coast of South America. It pushes all of that warm surface water towards Southeast Asia. South America gets that upwelling or that rise of the cool water. However, El Nino is when the trade winds slow or reverse directions, which stops upwelling and causes a sharp decrease in nutrients on the South American coast. So this hurts the fishing industry. La Nina is the opposite, where it intensifies the trade winds, so it causes major droughts in South America and extreme rainstorms in Southeast Asia. There are a variety of storms that can develop due to these weathered patterns. Tornadoes or twisters are swirling shaped funnel clouds that form over land. It occurs when a larger dry cold front runs into a very large warm front. The warm air passes over the cold air, and this ends up forming a vertical convection current. So again, instead of it just being kind of like a very like two fronts pushing on each other and moving it out of the way. When it is very large, it moves in quickly, and because it moves in quickly, it makes this vertical current. So you get that belt or loop, which causes your tornado to form. So you can kind of see them showing the loop here. Hot air's rising, cold air sinking. This kind of in the middle here, cold air sinking, which kind of helps to form this funnel cloud with our total upward current. Tropical cyclones are violent storms that form over warm ocean waters and sometimes pass over coastal land. These form when areas of low pressure over warm water draw in air from surrounding high pressure areas. The Earth's rotation then makes these winds spiral. The moist warm air rises through the cyclone's vortex, and spiraling continues until a cyclone is formed. Tropical cyclones are called hurricanes in the northern hemisphere, where they spiral counterclockwise, and they're called typhoons in the southern hemisphere, where they spiral clockwise. So just to give you an idea here, we draw in our warm, moist air. It goes up, it gets cool. As the Earth rotates, it causes the winds to spiral out. And then as the cool air descends, it drops rain. And then again, it kind of continues that loop.